Hello, this is Professor Kuehn, and we are discussing the work of Martin Waldseemueller, his Introduction to Cosmography, that is, the application of astronomy to map making. In my previous lecture, we talked about the celestial sphere and how there are a certain number of great circles and small circles that can be described on that sphere. The great circles that Waldseemueller mentioned were first of all the celestial equator, then the ecliptic, which is inclined at an angle with respect to the equator. Remember, that's the line through which the zodiac is drawn. The other great circles are the solstitial collier, which is a circle that passes through the 2 points of the solstices, that is Cancer and Capricorn, and also through the poles of the celestial sphere. That's the solstitial collier. Then the equinoctial collier, which is another great circle that's drawn through the 2 equinox points, that is the first point of Aries and the first point of Libra, and also through the poles of the celestial sphere. And finally, the 2 last great circles are the circle of the meridian, which is appropriate for every particular individual on the surface of the Earth. If you draw a circle that goes through the point of their zenith and through the poles of the celestial sphere, that would be their meridian circle, and also the horizon for that person, which would be the great circle that is drawn that separates the land from the sky, so to speak. So it divides the celestial sphere for an individual standing on the surface of the Earth into 2 halves. Then there are the 4 small circles: the Arctic Circle, the Tropic of Cancer, the Tropic of Capricorn, and the Antarctic Circle. You might want to review those before you go on. Okay, so that brings us to Chapter 4. And here what he's doing is he's talking more about these circles and giving some specific angular measurements. He's being a little bit numerical in this chapter. So if you look at Chapter 4 on page 108, he says that the celestial sphere is surrounded by 5 principal circles. That's what he talked about in the last chapter. 1 great and 4 small: the Arctic, the Circle of Cancer, the Equator, Circle of Capricorn, and the Antarctic. He's talking about specifically the circles that are horizontal circles. So if I were to draw the celestial sphere like this, and here what he's doing is he is talking about the specific locations of these. So if we were to draw the equator, remember that is the circle, the great circle that divides the celestial sphere in half. Let me put the North Star Polaris up here just to once again orient you. Then what we can do is, if we draw the axis of this celestial sphere straight down like this, and he mentions that the let me see. Well, let's first of all draw the ecliptic. So the ecliptic is this circle that goes like this. Oh, that's a kind of a bad line. Let me redo that. Start there and then do that also. So that's the line of the ecliptic, and he mentions in this chapter that this is at an angle. If I were to measure this angle right here, that angle would be 23 degrees and 51 minutes. So almost 24 degrees. So let's just round that off to 24 degrees. That is the angle of the ecliptic. And you might remember that if we draw this horizontal line across here, that would be the Tropic of Cancer, of course, because it goes through the first point of the constellation Cancer. And if we were to draw another straight line across right here through this bottom of the ecliptic, that would be the Tropic of Capricorn. Okay, so those 3 horizontal lines, the equator, the Tropic of Cancer, and the Tropic of Capricorn, are 3 lines that he talks about in this section. And now let's draw, actually let me make those in orange to emphasize them. Tropic of Cancer, the equator, and the Tropic of Capricorn. Now let me also draw another line that is perpendicular to the line of the ecliptic. This would be the axis of the ecliptic that he had talked about in the previous chapter. And the point where this intersects the celestial sphere, if we draw a horizontal line across here, And then also the point where it intersects down here, we get two more small circles, right there and there. And as you might recall, these are the Arctic Circle and the Antarctic Circle. Now, what are the angles of these? Well, we know that if this axis, the axis of the ecliptic, is perpendicular to the ecliptic line right there, then we know that this must be 24 degrees up here as well. And if this is 24 degrees, then this right here must be 66 degrees. And he mentions that in this chapter. He says 66 degrees and 9 minutes, or approximately 66 degrees. So let me draw this angle right here. That angle is going to be about 66 degrees. So the Arctic Circle is basically 66 degrees above the equator of the celestial sphere. The Tropic of Cancer is 24 degrees above the celestial sphere, the equator of the celestial sphere. And likewise below, the Tropic of Capricorn is 24 degrees below the equator, and the Antarctic Circle is 66 degrees below the equator. So those are some of the things that he mentions in this chapter. He also mentions that 1 degree is 1/30th of a sign. So when we talk about 1 degree in the heavens, 1 degree is, he says, 1/30th of a sign. Why do we say this? Well, remember, if I were to break the ecliptic up into 1, 2, 3, and then going around the back of the sphere, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12 signs of the zodiac. And so if there are 360 degrees in a circle, then each degree would be 1/30th of a sign. So again, he says 1 sign is equal to 1/12th of a circle. By this he means signs of the zodiac. Therefore, putting these together, he mentions that 1 degree is 1/360th of a circle. Okay, so he's giving us some ways of thinking about the measurements on this celestial sphere. And he mentions then that there are these 5 zones right here. The zone up in here of the celestial sphere, a zone in here. He calls this another zone in here near the equator between the two tropics, another zone down here, and another zone down here. If we go to page 109, the end of this is kind of interesting. He says, in this way, after having described these angles, he says, in this way, in the very creation of the world, there seems to be a wonderful order and arrangement. The old astronomers, in describing the form of the world, remember by the world he means the universe, the form of the world followed as far as possible in the footsteps of the Creator himself. So there you have an argument that this orderliness indicates that there's some kind of divine agent or creator or designer behind this. Of course, Martin Waldseemueller himself is a Catholic priest, and so it's clear who he's talking about here. The old astronomers, in describing the form of the world, followed as far as possible in the footsteps of the Creator himself, who made all things according to number, weight, and dimensions. So there is actually a reference to a particular verse of Scripture. This is from the book of Wisdom of Solomon, chapter 11, verse 20. So this is one of the apocryphal books of the Bible, the intertestamental period. And then he says, we too, while treating of this subject, inasmuch as we are so hampered by the conditions of our space that our system of minutes can be perceived only with difficulty or not at all, and if perceived would beget even annoyance as well as error, shall infer the positions of circles from the markings of degrees in full. For there is not much difference between 51 minutes and a full degree, which contains 60 minutes, as we have said before, and in the book on the sphere and elsewhere it is indicated in exactly this way by specialists on the subject. Therefore, in the diagram which we shall here insert for the better understanding of these matters, that's figure 9.2, I'll get to that in a moment, the tropics of Cancer and Capricorn, and the greatest declinations of the sun will be distant 24 degrees from the equinoctial, the same as the distance of the poles of the zodiac or the Arctic and Antarctic circles from the poles of the world, situated at an elevation of over 66 degrees. So he's mentioning here that to a good approximation, we're going to round off the nearest minute to a degree. And he's just going to write down 66 degrees, as I've done in this diagram, and 24 degrees. Okay, so if you jump ahead and look at that diagram on page 110, this is exactly what he's showing right here. I guess he's looking at the sphere from the opposite side that I have drawn it in this diagram. But so you've got Cancer and Gemini up on the left, upper left, and Sagittarius and Capricorn down on the right, whereas I have it reversed, but that's just because I'm imagining looking at the sphere from the other direction. Okay, so that's where he's indicating these different zones. Okay, and so let's now look at chapter 5. So the next chapter, chapter 5, he says, of the 5 celestial zones and the application of these and of the degrees of the heavens to the earth. Now this is where, after having this entire time been talking about astronomy and the divisions of this celestial sphere into zones and degrees and tropics and so on, now he's going to show how this can be applied to maps of the Earth. So he's going to take this sphere and project these lines down onto the surface of the Earth. And that is what he is doing then in figure 9.3. So if this stuff up here that I've discussed was in chapter 4 on the zones of the celestial sphere, now in chapter 5, what he's doing is he's applying this understanding of the celestial sphere to the surface of the Earth. Right? So if you look at this then on page 111, he shows on the outer part of this, he has the celestial sphere broken up into degrees around here. And then on the inside here, he has the Earth. Of course, it's blown up to look much bigger than it is compared to the celestial sphere. But the point he's making is if you take these lines on the celestial sphere and project them down onto the Earth, you will get, for example, the equator of the Earth, which is aligned in the same way as the equator of the celestial sphere. And likewise, if you were to take this degree, this 24-degree marking on the celestial sphere, that is the location of the Tropic of Cancer, and you were to project it straight down to point E on the surface of the Earth, you can draw a horizontal line ED around the Earth, and that would be the Tropic of Cancer on the surface of the Earth. So you probably learned when you were a young student where the Tropic of Cancer or the Tropic of Capricorn are on the surface of the Earth. You might not have known that these originated from the celestial sphere, which only makes sense because, after all, it's called the Tropic of Cancer because it goes through the first point of Cancer. Likewise, if you take this point 24 degrees south of the celestial equator and project it down to the surface of the Earth, you can draw a horizontal line FG on the surface of the Earth. That's the Tropic of Capricorn. And then finally, you can take these lines at 66 degrees north latitude and project them to the surface of the Earth, draw a horizontal line CB, that would be the region of the Arctic Circle, and also 66 degrees south latitude, and draw this line HK across the bottom, and that is the Antarctic Circle. And then he goes on to mention that these regions of the Earth then that are really denoted by regions of the celestial sphere are marked off based on regions of the celestial sphere. He labels these as the frigid region. That's zone number 1 at the top. Zone number 2 is the temperate region, he says, where most peoples of the Earth live. Then he says there is the Torrid region, which is between the Tropics of Cancer and Capricorn. And he says that these are uninhabited regions at first. Of course, he knows that they're inhabited. This is in the 1500s, people had traveled fairly widely. But he says, when we say that any zone of the heavens is either inhabited or uninhabited, we wish it to be understood that this applies to the corresponding zone lying beneath that celestial zone. When we say that any zone is inhabited or inhabitable, we mean that it is easily inhabitable. Likewise, when we say that any zone is uninhabited or uninhabitable, we understand that it is habitable with difficulty. For there are many people who now inhabit the dried up torrid zone, such as the inhabitants of the Golden Chersonese, and by that apparently he means Malacca, probably in India, the Taprobanenses, that is the people on the island of Ceylon, the Ethiopians, and a very large part of the Earth which had always been unknown, but which has recently been discovered by Amerigo Vespucci. So presumably there he's talking about the New World and the people who live in Mexico and Central America and northern South America. Okay, so we've got the Torrid Zone between zones E and G, and then zone 4 would be another temperate zone in the southern hemisphere, and finally the frigid zone on the bottom pole of the Earth. Okay, and then finally in chapter 6 of parallels, he says parallels, which are also called alemantars, are circles of lines equidistant in every direction and at every point, and never running together, even if extended to infinity. So he's talking here as something we would now call the lines of latitude, although he shows in table 9.1 a number of these different latitudes. And in this table, he shows what's examples of cities that are located at various latitudes, and their latitude, their degrees of latitude corresponding to what degrees of the heavens, that is the celestial sphere, are at their zenith. So for example, if you were to be standing in Rome, he said that's at 40 and 11/12 degrees north latitude. That is the point. If someone standing in Rome would draw a line straight upward and intersect the celestial sphere at their zenith, that would be at 40 and 11/12 degrees. And he also mentions in the second column in this table the greatest number of hours in a day. So this would be on the longest day, how many hours of daylight do they have if they're in Rome? And then also the number of miles in 1 degree. So presumably this is the number of miles if they were to travel 1 degree along their latitude, how many miles they would have gone. And you'll notice that the closer one is to the equator, the larger the number of miles in 1 degree. After all, that makes sense because the circle going around the equator is a much larger circle than the circle going around the Earth at the location of Rome, or for that matter, on the island of Thule, which is the highest known location that people had traveled to from Europe, presumably at that point.